How are you? I hope everybody is safe and healthy. I have missed you guys terribly, but now it's time to start learning again here for the rest of the school year. So here are my videos to help you learn, and we're going to get started learning via teleschool. So one more thing, if you can name this group and the title of this song, 1,000,000 points extra credit for you. All right, guys, hope to see you soon. Hi, everybody. Welcome back to Precalculus. I have missed you guys terribly, but now it's time for us to restart Pre-Calc so we can finish out the rest of the year. And I hope you enjoy these videos I make for you, and it helps you learn. So let's go ahead and get started. Bust out your notebook, and I need you to write down these 6 trig identities. These are called the sum and difference identities. Let me scroll up here. Why don't you go ahead and pause the video and write these down in your notebook. And then there's the last one. If you want to pause it, write down the last one. You can see they have some sort of pattern to them. We're going to do these a little differently than the identities that we had done previously, where we took one side and proved it to be the other side. This time we're going to actually get some number answers. We're going to spend all week doing just these identities. My plan is to do 3 lessons on these and do some review, and then we'll have a quiz on Friday, which I'll tell you about later. All right, let's go ahead and get the first example here. Well, first of all, I have a little statement down here. Why doesn't distributing work, in air quotes? You know that these two things are not nearly the same thing, right? This is a phase shift of 3, where this is actually a vertical shift of 3. So there's no way that you can distribute a sign. That doesn't work in trigonometry. So, as you can tell, right here we have a problem from Math Excel. These what your homework answers are going to, or problems are going to look like. It says write the expression as a sine, cosine, or tangent of an angle, okay, and then find the exact value of the expression. Now you're going to be expected to do these without a calculator. Okay? So if you look at all the trig identities, can you tell which one is like this one? Where it goes sine, cosine, then plus cosine, sine. Take a look at your identities, pause the video, and see if you can tell which one we're going to use out of those 6 for today. Did you guess the right one? That one is a sine addition identity. So what we're going to do here is use this identity and kind of work it out from here. Okay. Now what's in the theta spot? In the theta spot, there's 35. Okay. What's in the beta spot? In the beta spot, there's 25. All right. So the way I'm going to work this problem is this is going to be the sine of alpha. And what's in the alpha spot? In the alpha spot, there was 35 plus beta. What was in the beta spot? That was 25, right? So that statement converts to this. Now let's do something pretty easy here. Let's add 35 and 25 together. That's the sine of 60 degrees. Hey, the sine of 60 degrees, that's on the unit circle. Now, if you remember, 60 degrees, if I want to change it to radians, multiply by pi over 180, that's the same thing as pi over 3. All right, so this is equivalent to the sine of pi over 3. And then we look on the unit circle at pi over 3. And what's the y value? Radical 3 over 2. And that's our answer. Let's try another one. Okay, now which identity do you think we're going to use for this one? One that goes cosine, cosine, minus sine, sine. Why don't you pause the video and see which identity we're going to use to do this one. Okay, here we go. Let's see if you chose the right one. Right, that's the one. It goes cosine, cosine, minus sine, sine. Okay, and just like the first problem here, we're going to figure out what alpha and beta are. Now, what's in the alpha spot? These alpha spots are right here and right here. That's 5 pi over 12 that's in that spot. Okay, what's in the beta spot? 7 pi over 12. All right. Now that we've figured that out and we've used the right identity, let's go ahead and add alpha and beta together. That winds up being 12 pi over 12. Okay. All right. And which is the same thing as the cosine of pi. And the cosine of pi, that's on the unit circle. That's -1. All right. Let's try a third type of this problem. Why don't you pause the video here for a second and see if we can find which identity this one is. It's tangent and tangent on top with a minus, and 1 plus a couple tangents on the bottom. All right, let's take a look. There's the identity that we're going to use to do this one. Okay, you can see it's in the same form, right? A tangent minus a tangent, and a 1 plus a tangent times a tangent on the bottom. So let's go ahead and find out what this would be. All right. Can you tell me, guys, what is in the alpha spot? Alpha spot is like right there and right there. That's 40. Right? So we're going to use the tangent difference identity. Okay. Looks like that 40 is in the alpha spot. And how about in the beta spot? It's 10 degrees. Okay. That winds up being the tangent of 30 degrees. Now the tangent of 30 degrees, let's think about that in radians. The tangent of pi over 6 is what that would be. Okay. Now let's think about pi over 6 on the unit circle. Okay, that's y over x. So that's y over x, which reduces to, if you remember how we reduce these things, these denominators are the same. That winds up being 1 over radical 3. All right, Math Excel is not going to take that answer. All right, if you rationalize the bottom, that's radical 3 over 3 when you multiply up and down by radical 3. All right, now we got a second type of problem that we're going to do in Khan Academy, or excuse me, on Math Excel, and that is finding exact values of trig functions like the sine of 5 pi over 12 using sum and difference identities. Now, if you take a look at this problem, the sine of 5 pi over 12, I can split up 5 pi over 12 into two values that are actually add up to things that are on the unit circle. 2 pi over 12 and 5 pi over 12. That makes 5 pi over 12 when you add them together. Now, why did I do that? Because the sine of 2 pi over 12, when it reduces, becomes pi over 6. And 3 pi over 12 reduces to pi over 4. All right? And you can see that using the sum and difference identity of sine, actually it's the sum one for sine, Okay, that one is the sine of alpha cosine of beta plus the cosine of alpha and the sine of beta. All right, that's the sum addition one. Okay, and then again, let's play this game. What's in the alpha spot? There's the alpha spot. And then what's in the beta spot? This is the beta spot. So that's beta. This is alpha. Let's go ahead and plug those in there. The sine of pi over 6. Cosine of pi over 6 right there. Okay. And then in this spot, pi over 4. Pi over 4. And then from the unit circle, let's go ahead and find out each one of these values. Okay. The sine of pi over 6, you look at that on the unit circle, that's a half, times the cosine of pi over 4. Now, it's best to use, in this case, radical 2 over 2 to do those. Okay. Plus, let's find the cosine of pi over 6 on the unit circle. That's radical 3 over 2. And the sine of pi over 4, let's use radical 2 over 2. Now, let's multiply these fractions together. That's going to be radical 2 over 4. Let's multiply these together. Now, sometimes we forget maybe, how do you multiply those together? Radicals together like that. Radical 3 times radical 2, that's radical 6. 2 times 2 is 4. And look at that, they both have the same denominator. Okay, they're both over 4. Okay, now radical 2 and radical 6, can't add those together. So there's our answer for that one. Let's go ahead and try another one. Tangent of 7 pi over 12. Now there's many ways to do this problem. What do you think the best way would be to split up a 7 pi over 12? Let's think about a couple ways to do this. Okay. Can we add 2 pi over 12s together so they wind up to be 7? Okay. All right. You might think that there would be 2 pi over 12 and 5 pi over 12. Okay. Now 2 pi over 12, that's on the unit circle because that's pi over 6. But 5 pi over 12, that doesn't reduce, and it's not on the unit circle, so that was a bad choice. What might be another one at 2 radians that add up to 7 pi over 12? How about 3 pi over 12 and 4 pi over 12? Now, do these reduce? Okay, that winds up being pi over 4 when that reduces, and that winds up being pi over 3. Okay, all right. Now, this looks like the tangent of alpha plus beta. Okay, now what is the identity for the tangent of alpha plus beta? Okay, if we go back to the top, if you look in your notes, you'll see that that's the tangent, the tangent of alpha plus the tangent of beta all over 1 minus the tangent of alpha multiplied by the tangent of beta. All right. So, as we can tell from this problem here, in the alpha spot, there's a pi over 4. In the beta spot, there's a pi over 3. All right, so let's go ahead and plug those into our problem. That would wind up being the tangent of pi over 4 plus the tangent of pi over 3 all over 1 minus the tangent of pi over 4 times the tangent of pi over 3. Okay. So now we got to go to the unit circle and find these values. Okay. Now the tangent of pi over 4. Let's figure out these kind of on the side. Tangent of pi over 4, we look at the unit circle, that's y over x. All right, so that's 1 over radical 2 over 1 over radical 2, which winds up just being 1. Now, the tangent of pi over 3 on the unit circle, y over x. Right? In the y spot at pi over 3, that's radical 3 over 2. 1/2 is the x value, so this reduces to radical 3. So let's go ahead and put this in here. What we're going to have. Tangent of pi over 4, we said that's 1. The tangent of pi over 3 is radical 3. 1 minus tangent of pi over 4, that's 1 times radical 3. Okay. All right. Now, that is an answer I will accept on any test or quiz. Unfortunately, Math Excel doesn't. All right. Now, to tell you how to reduce all of this, I'd rather not do that. So let's go ahead and see if a CAS calculator can reduce it for us. Okay. So let's go to a calculator. Okay. And we'll simplify this. 1 plus radical 3 over 1 minus 1 times radical 3. And that's our answer. All right, negative radical 3. I'll take the negative through. Negative radical 3 minus 2. Okay. All right. And that's what our answer gets to be. Okay. Now, when we're doing this, use a CAS calculator. A lot of you have the student software. Okay. You can also use the website Wolfram Alpha and type that in and get the right reduced answer. Okay. Let's try one more of these and then we'll be done for today. Okay. The cosine of pi over 12. Okay. Now, there's no way that we can add 2 radians to get pi over 12. That's just not going to happen. So this is going to be an example where we're going to use a minus to split this up. Okay. All right. Now we need 2 radians that when you subtract them, you wind up with pi over 12. Okay. All right. Now, would 2 pi over 12 minus pi over 12 actually work? Those subtract to be pi over 12, but pi over 12 is not on the unit circle. 2 pi over 12 is because it reduces to pi over 6, but that would be a bad split up. So we'll try something else. All right. How about 3 pi over 12 minus 2 pi over 12? Will that work? I think both of those reduce. Okay, so let's give that a shot. So that's going to wind up being the cosine of pi over 12 minus pi over 6. I think the identity we're going to use this time is alpha minus beta. Okay, and this time it looks like our alpha is going to be pi over 4 and our beta is going to be pi over 6. Now to figure out what to do, we better write down the identity for that. You go back and look in your notes. You'll see that that's the cosine of alpha times the cosine of beta plus the sine of alpha sine of beta. This is what the cosine of alpha minus beta is. Okay. All right, so what's going to happen here? Okay. In the alpha spot, we're going to write pi over 4. Oops, wrong one. In the beta spot, looks like we got pi over 6. And now we'll use the unit circle to do this out. Okay. All right, so the cosine of pi over 4, that's a half. No. The cosine of pi over 4 is radical 2 over 2. Cosine of pi over 6 is radical 3 over 2. Okay. Plus sine of pi over 4 is radical 2 over 2. And the sine of pi over 6 is a half. Okay, we've seen this before when you multiply these two together. That's radical 6 over 4. Plus these two together, that's going to be radical 2 over 4. And that winds up being radical 6 plus radical 2 all over 4. Okay. Our homework tonight is that day 1. You guys give that a shot. And if you have any questions, you can feel free to email me and I can work out some problems for you from the homework. All right, guys. Once again, I miss you and I hope to see you soon. Thanks for listening.